How's it going, everyone? Eulier Gonzalez here again, looking now at the React performance. Um, Today we're going to focus straightforward on what we really care about, which is actually looking at the skip hatches, and I'm going to recap everything that we have learned so far, because at the end of the day I want you to dive deep into the life cycle of React effects. As a way to recap is these specific sections, and then finally getting to the synchronizing with effect. You might not need an effect, life cycle of effects, and separating event from effects. So let's get into it. All right. So because as a way to briefly describe is what is this describing the UI, or in particularly React. So React allows us to write is UI, describe it, using is JavaScript. So by creating JavaScript functions, we can now have the ability to describe as this user interface. We also look at how can we import components, export them, as well as passing data down to these components, using GSX as a way to now render HTML tag, combining with JavaScript, rendering conditional elements, lists of elements, as well as how important is for React that you write your components in a pure way, because it comes out with some benefits. It allows you to run your components in any JavaScript environment. So for example, on the server, it also allows you to catch that component, so you save computational time, as well as when it comes to now pass down data to your render tree, you can safely stop it and resume or replay that rendering. And how the rendering tree and the tree dependencies is the way how React see your components, the render tree, so you can get yourself familiar with how the data flow goes through, as well as you can identify any performance issue. And the how do you put it? The tree of dependency, which is logic that you're gonna put inside of your React component as a way for these components provide some interactivity, because otherwise we are just writing is plain HTML. So because of that, we look at how can we add interactivity by using is the curly braces as a way to now provide is functions from JavaScript and attach to them to the event listener, okay? And when it comes to actually show data, use this thing called state, which is a component's memory. So for example, if you're gonna show or if you're gonna look in your banking app, your balance, your transaction history, your credit card information, that kind of thing, all of this information is being stored using is or can be stored using a state. So this state, when it comes to actually update that, for example, when you want to actually send money to your mom, all right? Once that transaction actually passed through that, all right? So that transaction is guaranteed to be fulfilled properly, whether it is using is Postgres or MongoDB or any of all of the intermediary between the client, your cell phone or your device, and the server, as well as the account that you want to update, and then be reflect that on your mom's device. Okay, all of that thing. The idea here is to be able to now do that in a proper way. So once that transaction has been complete properly, all right. So this states the way you can now update your state. For example, sending money to your mom, sending money to your mom, is by now updating that you do that is inside of your event handlers, and anytime you trigger that and the state updates, then React passes through a rendering mechanism that is caused by state updates. And it has several phases. You have the trigger, the render, and the commit. So on the trigger is when it detects when this event happened at the root element or any component or any ancestor if it is these components that trigger and state updates. The trigger, the rendering phase, when it say, okay, let me now call this function. If this was caused by the initial root element, I'm going to create that element for that. I'm going to create all of these elements for that. If it was caused by a re-render, meaning that a component trigger this state updates, I'm going to calculate all of the props, hooks, and variables, event handlers, store that information to be later used on the next phase, and the output of that component, if that contains more React components, I will continuously call that in a recursive way until there is no more component. While doing this, React create now or recreate is the VDOM, which is this ideal representation of the UI that is kept in memory and sync with the real DOM. This process is known as the reconciliation. So this is also what allows you as a developer access to the React API and tell React what your UI state you want to be, and let React now match that state with your DOM. So this process here, and by passing some additional information to the VDOM, is what's now, they call this as Fiber, which is now the reconciliation engine here. This reconciliation engine, which starts from React 16, as a way to now lay down the foundation of what we are capable of, all right, on the web, specifically to solve specific Facebook problems, okay, in terms of rendering prioritization. Hey, when I want these components to be rendered, to be called, rendering prioritizations. The other is concurrent rendering, when I want these components to be rendered in parallel, simultaneously, okay? And also is now the ability to pause, start, or stop, or the ability to stop, play, start, resume, or stop your components, the rendering of a component. So all of this React Fibers is a way of how now you can describe when you have to explain that React Fiber to somebody, especially your college and that kind of thing. You say, okay, now this React Fiber, this is what allows us is this specific or this reconciliation engine that behind the scenes is now is the VDOM, as well as the diffing algorithm, as a way to now on the commit phase, when React now they have all the necessary data to apply all the DOM change, if this will happen at the initial root, then it's going to append all of these elements using the append DOM, all right? If this was caused by a re-rendering, then we're going to apply only the bare minimum necessary change, as long as they are different between renderings, and do that. So once the browser detects those DOM updates, now it is time for the browser to paint that, so you can see the UI. And this process is something is mechanical and happening over and over at now sim. So when we know that, and also how our state works on every rendering as a snapshot, which means that the state value, the variable state value, you will gonna see reflect those changes in the next render. And you can think that React during the event handlers is going to fix the state updates. And how from there, when you want, for example, work with previous state as a way to now queue series of state updates. You can do that by passing in an arrow function to that. All right. Then we look at mhm, yeah. Mhm. Uh, so yeah, so then we look at the uh, how you can now is updating objects and arrays in a state. The TLDR of that is always returning a new state. You can use this iMerge for state update consists in immutable syntax. How we can also manage our state as our applications grows and we need to also define all of this user interface. How useful is to think your UI state as state change by following is this particular principle of declarative versus imperative, which means that now you will have the ability to is identify, so by identifying all the different visual states and then the determine what trigger those state updates and therefore represent those state with user state in your memory, so you can now is avoid any non-essential states to keep them simple. uh, so you ultimately is now connect the handler with the user state. Now it makes a lot of sense as a way to now organize your state, and following is this principle that now React provide, like group related state together, avoid any non-essential, avoid contradictory states, redundant states, redundant states, mm, avoid redundant states, contradictory states, duplicate states, and all nested object in states. So then when it comes now to share that state across different components, now you see how important it is for you to, whenever you define which components owns this state, they'll become is the source of truth for all of the other component that needs to. And how now you have, for example, is libraries, all right, like Substand, for example, or Redux, for example, all right, for example, like Substand, for example. Is making it much more uh, easy to work with. So instead of using all other libraries like Dispatch and that kind of thing, it's like, or the documentation here. A small, fast, scalable, bare-bones state management solution. Sunstand has a config API based on hooks. It isn't boilerplated or opinionated, but has enough conventions to be explicitly like Flux-like. Don't disregard it because it is cute. It has claw. A lot of the time was spent to deal with common pitfalls like the dread zombie children components, React concurrency, and context loss between mixes rendering. It may be one of the state managing React space that gets all of this right. Again, if you require for this, okay, if your application require this kind of thing, all right, still props on children, on zombie children. stealth props, and zombie children. Use mutable source. But again, this is very narrow, specific problems. Support cross-render portals. So, but the problem here is that it's solving a specific problems. How these specific problems actually rise in your application, it is up to you. You know, how all of this fits in your application, it is up to you. But again, the idea here is that if you're going to use a particular library, all right, so if you're going to use this a particular library, like so, stick to that in any case, because when it comes now to deal with more, so the more inputs you need to handle, because now they mention something called like the React or these components, like uncontrolled components and control components, and uncontrolled components are components where now their main informations are driven by the state, and uncontrolled in control components are data where is now, so the main data is now driven by these props. Okay, and you can mix this one of things, even though that, because we mentioned here now how all of this state management actually works. Okay, as a way to say, all right, now we can is having a centralized place where we can now put all of our state logic. All right, so we can share all of this to common child using Redux. When it comes now to React, for the lack of a word, to more inputs in an state, it become much more easy, and it'll make much more sense to say, let's gonna find out a way to make this manageable and maintainable using Reducer. So Reducer is something that I really look at that. This is a custom hooks I provide now for React. The initial value is the Reducer function, where in there you're gonna pass is a function, or you're gonna define as a function that where you're going to pass is the state, and or that it receives the state and then actions to generate a new bit of a state out of that, as a way to have much more consistency and control when you're going to trigger those state updates. And if you want to update a state that is not defined in an action, or you want to trigger an action, you want to dispatch an action that is not well defined, or does not exist, you're gonna get an error. So this is a way of how we can put all of this guardrail, especially when we need to react to more inputs, when a state needs to react to more inputs. So this is from the front. This is now using is Reducer. Okay, and when it comes to actually update that or dispatch that state, we call that function from the use Reducer, passes the array from that, or passes the object with the type of the name of that action that we want to dispatch, and therefore is the data that we want to update to our states. And then how can we know is look at how we can reset the state, preserve the state. How useful is this when it comes to actually show a component from the scratch, when you mount a component, unmount and remount that component. by default now React actually is the same component at the same position of the React now preserve the state at the position of the tree, of the render tree. So if your components, if you have several components, if you have the same if you have the same components rendering at the same position of the tree, React will preserve the state. If you render different components, React will reset them. If, for example, you want to now reset the state of the same components at that position, React will now is to tell you, hey, you can just render that component in a different position as a way to reset that, or put a key for that. And also we look at how can we now pass data to distant components as a way to solve this problem known as props drilling. And from there, now you can is by using context solve this particular problem. When you provide the context, you now use a context using the use context hooks, all right? And the main use case for this is for small app level data, for theming, for perhaps analytics or user authentication data. The React router actually is using that, by the way. And when it comes now to manage, or when you need to handle is the more inputs a state needs to react in a context, it makes much more sense to combine that with a reducer. And how there is a caveat of using our context, because React will re-render that components. React will re-render that components that states update. React will re-render that components. React will re-render all of the children components that have access or that use that context starting from the provider, that value change. So one optimization technique is that instead of actually you putting some of your values in your providers, you can is in a state. So when you update that, you can put them into a memo as a way to now catch that data. So save computation times or catch between re-render. Similar with use callback, but for functions. So when an array of dependency changes, all right, I want you to actually now update that. Therefore, all of the children components that make use of this specific context, they're gonna be rendered. So then we look now at how you can communicate with external systems and how helpful and important is to do this. And this is this. How helpful it is to do this, which is how helpful it is to do this. So how we can now is, for example, connect to external systems, okay? Whether it's to input a focus by using is useref. What is useref? Which is a secret pocket that you can think of that now you're going to remember things between re-renders without trigger a re-rendering. And the main use case of this is by using is the timeout ID, or by grabbing an element from the DOM And if you want, for example, this render, let's say you want to pick up the canvas. And from there, when you get that, you want is to actually work with that canvas as a way to render something, let's say bounding box. Okay, so once you detect that context, then you're going to now render that render 2D graphics on the fly. Okay, using JavaScript, of course. So as we look at this and we progress and we will move on, which is something interesting. The other use case is for save an object between re-render. Okay, so if you wanna save an object reference, well, you can use the ref for that. We also look at what is the main use case when you use a ref to manipulate DOM elements. So, for example, is to calculate the size of the screens, or to scroll, to access to the scroll event, or to focus on an input. All right. So this use ref sits between the commit, because now before the commit happened, it is initialized. After that, it is assigned its value. And then we look at the use effect and how would the effect allow us to synchronize with our external systems. Okay, so because of that, it is important to take a look at what is the logic on how you can define the type of logic that you can have inside of your React components. The rendering logic that must be pure, and then the event handler logic, that in there is when you can now perform some side effects, aka you can talk to a server, for example. So because of that, the React team community, they say it'll be better when you want to run now this side effects or code that alter is the program functionality beyond its primary purpose. For example, it modify a global variable or a data store or a data structure, or perhaps is talking to external systems, the input and output. So for this particular case, it will be helpful and it is safe for this code to run after the component rendering itself, but and after so this code will run is when the component is rendering itself at the end of every commit phase by default, which means that after the screen update, now this piece of code is when it's going to run. This logic that you want, for example, is to mutate your data structure. You shouldn't do that. Say mutate your data structure or your global variables. Perhaps you want to talk to or you want to perform input and output operations. So it is in this moment, in this place where you can now put that. So initially we look at sometimes how you might not need an effect, because most of the time your logic shouldn't rely on this type of, so your data flow and most of your application logic shouldn't rely on this feature. So because of that, we look at how you can describe is your use effect, and that initially happen is after every commit, because we don't want to do that. This is also a built-in hook, use effect. Then you can now specify an array of dependency as a way to trigger this side effect code when a reactive variable change or a dependency change, and we're going to talk about that reactive values. And then we can now for example, after you subscribe to an external system, you also want is to desubscribe or unsubscribe or disconnect, right? You have connect, disconnect, subscribe, unsubscribe, and that kind of thing. So the anatomy here of this use effect, which is something that we're going to dive into that, is that now we have is the set of code where here is when we define is the subscription or the synchronization, stop synchronization, and then our cleanup code is stop synchronization. So when you write your effects, and because now React 18, if you're using is a strict mode tag that provides from React as a way to prevent some of the common gotchas and bug fix, or some of the bugs, for example, in your state or your effects. So they rerun your effect twice, as well as your components. So that's one of the things when you're in the development mode using the effects, how important it is to not get rid of the second render, but how you can synchronize your effect to work with to unsubscribe with the cleanup function. So this is based on their docs, okay? And because of that, then we look at when you write your effects, it will typically follow this particular pattern. Or you write you synchronize with non-React widgets. So for example, like Map, Mapbox, MapLive, any other system, all right? Libraries as well. Animations, you want to subscribe to events. So for example, a window objects. So a window object is not exclusively, for example, other type of events in browser, okay, browser events here. Give it to me in English, okay. So for example, like animation, clipboard, and I really love about this event index. Okay, interesting. Creating and triggering event handling. Exactly. Events are fired to notify code of interesting change that may affect the code execution. But again, for example, most of the time we're quite familiar with this, all right? Like XML HTTP requests or abort signal, file reader, clipboard is another one. Event fires on document, element and window, composition. Event related to composition, entering text indirectly rather than using normal keyboard press. CSS transition. This is an event fires on document. Database. This is very not specific to this. Something that we're not going to use. DOM mutations. Mutation events are deprecated. Mutation observers should be used instead. Mutation observer. Provide the ability to watch for change being made to the DOM tree. It is designed as a replacement of the older mutation event feature, which was part of the DOM 3 event specification. Okay, when an event change, when a DOM element changes, I want you to know more about this. Drag and drop wheel, focus, form, full screen, gamepad API, gesture, history, inputs, keyboard, loading, unloading documents, manifest. I think this is more for like a progressive, PWA, media capture and string API, web audio API, picture in picture, messaging. If you want to send events related to a window receiving a message from another browsing context, events related to use a computer, mouse. Network payment. This payment request API is not that quite implemented sometimes. Like sockets, touch, real-time communications, server-sent events, and workers. But as you can see, this is all of the events that you can, and after all, most of the time you're going to subscribe to that. Okay, subscribing to an event, all right? Holy moly. Subscribing to an event, okay? Triggering animations, now fetching data, which is also part of the triggering an event. But this is a very interesting case because when you do that, since there is no way to undo a network operation, the way they set that is by putting a flag, and when that flag is putting a flag, run the async run so fetch the data. When you fetch the data, now you want is to fetch the data, uh, and when you want, for example, now update your state with new fresh data, you want is to forget the old data. All right, that's why in the cleanup function they define is this flag as false or as true in that case. So why this is important? Because again, this is a very specific way of how you can now do what the 95% of the most applications out there are doing, which is data fetching or sending data. Okay, especially web apps. So because this is data fetching, and even though that this particular approach works significantly good, all right, it comes with some trade-off, and the trade-off is that because now you will have is to deduplicate requests. It means that your effects doesn't run on the server. It's the server that actually render the HTML, send that to the client, show the loading state. Now the client fetch the relevant JavaScript code, now add interactivity, and then only realize that it needs to perform is a network request to fetch the data. So you need to handle you need to avoid the duplicating requests. Also, you need to find a way to catch some response, because when the component is mounted and unmounted and remounted again, you don't have that data there. Okay. And also, if you have several components that are fetching a specific data from that, for example, you have a bank account, when you have now the summary, you have this transaction history, you got this profile data, all of these different UI are fetching data from that. You need to actually deal or avoid this network waterfall. So frameworks like Next, Remix, and Gatsby provide you to that. It comes with these built-in tools, but it comes also with some challenge, like any solutions. Okay, and also when it comes to and when it comes to so when it comes now to use some client-side fetching libraries, you can go with use SWC, that's one of them, or the React Router, React Query, or you can implement your own using use effect, and to avoid and find a logic to avoid is the duplicate network requests, network waterfalls, and provide caching mechanism, which is not trivial, similar to the routing. And also another typical use case here is sending analytics in your use effects. So when you might not need an effect, if you find yourself in the need to transform your data during rendering, you don't need an effect. Remember that after all, the effect is a way of how you can now connect to an external system. If you don't need to connect that, or if your state depends on other state updates, then you don't need an effect. Okay. And the other is that you don't need an effect for handling user inputs. So that's why we look here at updating a state based on a props or a state. If that is the case, recalculate them using this or defining as a new variable to recalculate that when you need to updating an state based on a props or an state. So catching expensive calculations. So it's better for you to go with the use memo for that. based on a property that you are receiving for that, right? Like memorization. Okay. The other is, again, I'm just looking at this specific business use case because they are great, because they now identify that something that you're going to definitely see as you move on and you build all of your UI for a particular client or company, that kind of thing. It's like, it'll makes a lot of sense. Okay. So the other is resetting all state when a prop change. Do not use an effect. Use a key for that. Adjusting some state when a props change. Instead of doing that, you also calculate that. So whether it's if you're updating an state or based on you're updating an state based on a props or an state, or you're adjusting some states based on props change, again, define them as a new computation. Okay, adjusting some and this is something important, especially when you're going to see a particular code. It's like, what do I need to do here? Do I need to updating or adjusting some state to the props change? Okay, or do I need to do something else or that kind of thing, and so on and so forth? Okay. Uh, so yeah. Yeah, adjusting some state when a prop change. That's right. The other is sharing logic between event handlers. So you don't need an effect to actually handle user events. In fact, you can create now your the logic that you're gonna share across different event handlers. Sending a post HTTP request, you don't need an effect. You just only set that on your event handlers. Change of computation. Instead of, because of, you can think of your effects as an independent process here. You might feel the temptation to create now is a piece of code that actually connect as a way to now update an state. Does not do that inside of your event handlers and handle those chains of computation there. And handle all of those computations. Say, for example, this chains of computation when you actually need to compute that. Remember that the use effects are only for communicating to external systems. The other is initializing the application. If you need some boilerplate, some code that it needs some initial state, do that before the app get mounted, if that's the place where you need to. Or if you want to these things, or you think that you need to actually is to update this data inside of your app, then consider to do that, right? But again, don't use an effect for that. Only runs once per app loads, like this. Check if we are running in the browser, and only runs once per the app load. And the other is that notifying pattern components about state change. Well, you leave the state up and then you do the inverse flow. This is one of the things of thinking in React term, which is when you're going to define your UI components, you will need to have the mock, you have the data, and then, all right, you're going to now create the component hierarchy here, the UI component hierarchy there. If you use now is the data, that's actually falls naturally into this component, because usually the UI and the data model have the same architecture, aka the same shape. So you can now is Mm-hmm. Okay. So now you can now is actually is pass down data to from the patterns to the components. Okay. And the other is that passing data to the patterns again. So if you want to notify exactly, so notify components data about state change, you emit that you emit that event. So you receive that event and then you emit that. If you want to now pass data to the parent, you make that you lift that state up and then you pass down to the component as a way to preserve is the one-way data flow. So because I was talking about is the thinking in React and how important it is for us to say, hey, when you're going to write your components, you will need to have is the always is the data and the warframe. Okay, some of them are provided by the designers or the database, but you need to have at least one of them, and then you're going to create your component UI hierarchy as a way to identify, hey, which one of these components actually will fall into that. If you have the data model, it'll be great because now you will now have it naturally falls into together because as I mentioned, the UI and the data models actually have the same shape. Okay. If you have now the mock, you can see the UI design layer that they provide to you. All right. Uh, even though, all right, even though the idea of looking at this is because when it comes to now uh, create your or thinking in React to build a specific UI, okay, then you're going to create a static version of your UI from the data models by passing this down data, and then you want to find the minimal but complete UI represent or the state representation of your UI state. Most of the time, that is, if this data doesn't change often over time, that is not in a state. If you get this data from its props or from another state, that's not an state. Uh, if you get your data from its props, that's not an state. If you can recompute your data from its props or from its state, or if you can recalculate that, now that's definitely not a state. What left is probably a state. So then you are going to then you are going to now okay. Then you are going to connect those states. I think it is. Okay. Then you're going to identify where those states should okay. Then you're going to identify where those states should live in your components, okay, because they will be now the source of truth. And remember that because most of the time when you mocking requires a lot of typing and less thinking, where now adding interactivity requires a lot of thinking and less typing. So when you define when you find the minimal UI, when you define the minimal but complete representation of your UI state, now it is time to identify which component uh, owns that state, and therefore now add the inverse data flow, which means that you're going to now pass the state and the event handlers to that component, to the child component, and then they're going to now emit that event or update that event, right? So I think this is quite interesting and illustrative because as I now understand when you might not need an effect and understand is the life cycle here and how important to think of your effects that do two things only. One of them is start synchronizing or start synchronizing something and then later on stop synchronizing. So this cycle can happen multiple times if your effect depends on props and a state that changes over time. React provides a linter rule to check that you have specified your effect dependency correctly. This keeps your effect synchronized to the latest props and a state. Okay. Okay, but I think this in this hour I summarize all of the React. Uh, I summarize vastly, and now I can have access to all of this information, and to me that's quite powerful. Completely, bro. To me, it's quite powerful because now I can dedicate its time to this. So that is the life cycle of an effect, where they say every React components go through the same life cycle. You mount, update the components, and then you unmount. So it is important to think your effect as single separate thread or a single separate or as a separate life cycle from your surrounding components. Each effect describes the synchronization process that you can start and stop. This is something quite interesting. Each effect describes a separate synchronization process that can start and stop. So when you write and read effects, think from each individual effect perspective. And again, this is one of the things when you are now writing your effects here in a, by thinking them in a separate synchronization process that you can start and stop. And when writing an effect, think from each individual effect's perspective. How to start and stop synchronization rather from the component perspective. Values declared inside of the component's body are reactive. Therefore, they are changed over time. It's going to depend on your logic, but they are going to change over time. This is one of the core things when now frameworks like Vue and that kind of thing, they adopt that and say, hey, it'll be great to use this or implement that and that kind of thing. Okay. So reactive values should be resynchronized. Okay, reactive values should be resynchronized. The effect because they can change over time. Reactive value should be resynchronized, which means is that whether it's a props or a states or a variable that you define inside of the React component body, reactive values should resynchronize the effect because they can change over time, meaning that you can use this as your dependency. The linter verify that all reactive values used inside of the effect are specified as dependency. And if you don't need to react to that, okay, React verify, okay. And for example, if you don't need that, what to do when you don't want to resynchronize, okay? Well, you can put that as outside of the function, outside of the components. Any variable you define inside of the component's body, it becomes reactive. Therefore, you need to synchronize with them. And if you don't want to, you can safely or define outside of the component or inside of your use effect. Most of the time, you're not gonna see this kind of thing. because you're going to rely on a state management that actually handles that thing for us. Okay. And effects are reactive blocks of code. All right. So like event handler, which only runs per interaction, effect runs whenever synchronization is necessary. You can choose your dependencies because your dependency must include every reactive value. The linting for this, the linters say, hey, because use effect represents is a synchronization process, okay? Because each use effects describe a separate synchronization process that you can start or stop. Think of the use effect from the use effect perspective, and when you need in and for example, when you're going to define some dependencies in your effect, they need to be reactive. Therefore, any variables or values you define inside of your component functions are reactive. So reactive values should resynchronize the effect because they can change over time. So reactive value should resynchronize the effect because they change over time. If you don't want that, if you don't need to resynchronize them, put those outside of the function body, of the component body. And separating events from effect. Event handlers only reruns when you perform the same interaction again. Unlike event handlers, effect resynchronize if some values they read, like a prop or a state variable, is different from what was during the last rendering. Sometimes you also want a mix of both behavior, an effect that rerun in response to some value but not to others. This page will teach you how to do that. Hey, I want you to now run this side effect code as a way to respond to some values but not others. How to choose between an event handler and an effect. Why effects are reactive and event handlers are not. What to do when you want a part of your effects code to not be reactive. What to do when you want a part of your effect code not to be reactive. What effects events are effects events, and how to extract them from your effects. How to read the latest props and state from effect using effects events. Okay, so event handlers only rerun when you perform the same interaction again. Exactly, event handlers only rerun when you perform the same interaction again. Unlike event handlers, effects resynchronize if some value read, like a prop or state values, is different from what it was during the last rendering. So sometimes you also want a mix of both behaviors, an effect that reruns in response to some value but not others. Choosing between event handlers and effect. First, let's recap the difference between event handlers and an effect. An event handlers is this logic that allows us is to perform some side effects, okay, based on a input, based on a user input. Where now effects are side effect code that is run after every commit phase by default, but you can specify an array of dependency to change that. Let's say you already implement the code for them, but you are not sure where to put it. Should you use event handler or effects? Okay, let's say, imagine you are implementing a chat room. Your requirements look like this. Your component should automatically connect to the chat, to the selected chat. So when you click send button, it should send a message to the chat. So let's say you already implement the code for them, but you're not sure where to put it. You should use event handlers or an effect. Here, your component should automatically connect to the selected chat room. You are now connecting to an external system. All right, do this. When you click the send button, it should send a message to the chat. So now this is an event. Every time you need to answer this question, consider why the code needs to run. Why the code needs to run. So for example, why this code needs to run as a way to synchronize with an external system is an effect. In this case, when you click the send button, you send a message to that you want is to send a post to because you want is to send a message to the server. That is just an event. There is no synchronization. There is no synchronization process of that. Only sending data. Should you use an event handler? Event handlers run in response to a specific interaction. Okay. Choosing between event handlers and effects. Events run in response to a specific interaction. Event handlers. From the user perspective, sending a message should happen because the particular send button was clicked. The user will get rather upset if you send their message at any other time or for any other reason. This is why sending a message should be an event handler. But again, events handler run in response to a specific interaction. Effects run whenever synchronization is needed. This is the key concept here. Recall that you also need to keep the components connected to the chat room. Where does the code go? The reason to run this code is not some particular interaction. It doesn't matter why or how the user navigates to the chat room screen. Now they are looking at it and could interact with it. The component needs to stay connected to the selected chat server. Even if the chat room component was the initial screen of your app and the user has not performed any interaction at all, you will still need to connect. This is why it is an effect. Exactly. But again, event handlers are triggered, or event handlers run in response to a specific inputs, or to specific interactions, or to specific events. So effects run whenever you need to synchronize with something. So with this subtle difference, reactive values and reactive logic, okay, intuitively you could say that event handlers are always triggered manually. Exactly. For example, by clicking a button, effects on the other hand are automatic. They will run as often as needed to stay synchronized. There is more a precise way to think about this. Prop states and variables declared inside of your component body are called reactive values. In these examples, prop states and variables declared inside your component's body are called reactive values. In this example, server URL is not a reactive value, but room ID and message are. They participate in the rendering data flow. Reactive value like this can change due to a re-render. For example, the user may edit the message or choose different room ID in the drop-down. Event handlers and effect response to change differently. Logic inside event handler is not reactive. Logic inside effects is reactive. So it will not run again unless the user performs the same interaction, and they call this manually. Okay. Reactive values and reactive logic. So you can think that the event handlers are always triggering manual, and the effects are, on the other hand, automatic. Okay, they run and rerun as often as is needed based on an array of dependency. That's right. But there is a more precise way to think of this. So any props, states, and variables defined inside of the component's body are called reactive values. So in this example, server URL is not a reactive value. The server URL is not a reactive value because it's not defined there. Okay, and they participate in the rendering data flow, the room ID, and the message. So event handlers and effects respond to change differently. The logic inside an event handler is not reactive. It will not run again unless the user performs the same interaction. Event handlers can read reactive values without reacting to their change. Logic inside effect is reactive. Okay, so the logic, okay, is now separating the width. Okay, separating the width here. Separating the width. Reactive values and reactive logic. Logic inside event handler is not reactive. Take a look at this line of code. Should this logic be reactive or not? From the user perspective, a change to the message does not mean that they want to send a message. It only means that the user is typing. In other words, the logic that sends a message should not be reactive. A change to the message does not mean that they want to send a message. It should not only run. It should not run again only because the reactive value has changed. That's why it belongs in the event handlers. Event handlers aren't reactive, so send message will only run when the user clicks the send button. Logic inside effects is reactive. Now let's return to these lines. From the user perspective, a change to that room ID does mean that they want to connect to a different room. In other words, the logic for connecting to the room should be reactive. You want this line of codes to keep it up with the wait a second. So logic inside effect is reactive. Logic inside effect is not reactive. So logic inside events handlers is not reactive. A change to the message does not mean that they want to send a message. Like this. It should not only run only because the reactive value has changed. That's why it belongs to the event handler. Logic inside effects is reactive, which means that it's going to change over time. From the user perspective, a change to the room ID does mean that they want to connect to a different room. In other words, the logic for connecting to the room should be reactive. Exactly. This logic, but it's about the logic here. It's about the logic, separating events from effects. It's about the logic. Hey, this logic is going to do what? It's going to now synchronize with an external system. Okay, is reactive this logic? All right. If this logic is not reactive, I'm gonna put it that inside of the event handler, extracting non-reactive logic out of the effects. things get more tricky when you want to mix reactive logic with non-reactive logic. For example, imagine that you want to show a notification when the user connects to the chat. You read the current theme, dark or light, from the prop so you can show the notification in the correct color. However, theme is a reactive value. It can change as a result of re-rendering. However, theme is a reactive value. It can change as a result of re-rendering. And every reactive value read by an effect must be declared as its dependency. Now that you have specified theme as a dependency for your effect, exactly every reactive value and every reactive value read by an effect must be declared as its dependency, because this change over time and this logic is reactive. So when the room ID changes, the chat reconnects as you will expect. But since theme is also dependency, the chat also reconnects every time you switch between the dark and the light theme. That's not great. In other words, you don't want this line to be reactive, even though it is inside an effect which is reactive. So on connection, you want to do this. So because this is now a reactive logic, hey, when this is connected, and show now that connected. So when the room ID changes, the chat reconnects as you will expect. Exactly. And then it's gonna show this notification, this logic here. But since theme is also dependency, the chat can also, okay, that's not an ideal. But since, okay, if the theme changes in this particular case, okay, if the theme changed, it also changed, and that's not an ideal. Okay, and that's not great. In other words, you don't want this line to be reactive, even though if it is inside an effect which is reactive. Declaring an effect event. Okay, and this section describes an experimental API that has not yet been released in a stable version. Use effect event. So now this will be rendered. You can think of events as being very similar to event handlers. The main difference is that the event runs in response to a user interaction. In response to a user interaction. Exactly, in response to a user interaction. in response of a user interaction. But now if you show this here, for example, like theme, if you now define here the theme here, okay, but this is now okay. This is now on development. Only call them from inside effects. Never pass in to other component or hook. We are now reached to that. Fix the variable doesn't update. Removing effects dependencies. Okay, reusing logic with custom hooks. Separating events from effects. This is something important, especially as a way to now recognize this particular concept of the reactive logic and non-reactive logic. And when you're going to think about your effects and your events, so your effects responds to your events responds to a specific interactions, and your effects run to synchronizing or whenever synchronization is needed. Holy moly. That'll be all for this video. Take care. Bye bye.